From data.info we are getting 25 non-null values, which means that there are no null values in the data, so we don't have to take care about the null values. It also tells us that the R's variable is a float type of variable and the score variable is an int type of variable. So we'll plot the scatter plot of the two variables where the number of hours studied is on the x-axis and the scores obtained is on the y-axis. So from the scatter plot we can see that there is a fairly linear relationship between the two variables, and this can be validated with the help of correlation coefficient. So the correlation coefficient we are getting is 0.976, which is fairly equal to 1 and in positive value. So this means that there is a positive linear relationship between the two variables, which implies that if the number of hours increase, the score will also increase. So here we are plotting a distribution plot of the two variables, and we are getting that the variables are in a particular range and there are no outliers in the variable. So if there are no outlier, it is good for a model because outlier affects a model to a great extent. So here is the model which we are using. This is the linear regression model. In this we are first dividing a data into train and test data sets. So 80% of the data is into train data set and 20% is into test data set. So in linear regression, basically what scikit-learn internally does is it finds a line. Basically it finds the slope and the intercept of the line where all the points fall. But after seeing the scatter plot of this data, there cannot be any line in which all the points falls. So what scikit-learn does is find a line in which the difference of the predicted values of the line and the actual values of the point is minimum. So basically what we have to do is the sum of the difference of the predicted values and the actual values of the score has to be minimum, and this creates an optimization problem which scikit-learn solves internally. And thus these are the two outputs of the model, which is the slope of the line and the intercept, so which is denoted by M and C. So this is the target values which we already got in the data and the predicted values which the model is predicting. And we are also plotting a distribution plot for the difference between the target value and the predicted value. So this difference is also very close to 0, and it is in the range of -5 to 5. So it basically tells that our model is fitting the data well. So our main task is to predict the score for a student who studies for 9.25 hours per day. And here we are getting 91.56% score for a student who studies 9.25 hours a day. And this is the model evaluation. We are using two performance metrics for the model evaluation. First is the mean absolute error and the second is the R-squared score. So the R-squared score, we are getting a high R-squared score of 0.97, which is a good score, and basically it tells that our model is predicting 97.1% of the data. Thank you.